is the diagram we're trying to explain. And this is what happens at the axon hillock in response to a stimulus that reaches threshold. Now, okay, so we know it's dependent upon voltage-gated sodium and potassium channels. Where do you have these voltage-gated sodium and potassium channels? You have them anywhere you're capable of generating an action potential, because they're what give you the action potential. So you don't have them on dendrites, you don't have them on the cell body, but you do have them where? You have them on the hillock, and you have them on the axon. And they're all the way through the axon, all the way down covering the terminal. The reason the action potential, once you're at the hillock, doesn't spread back through the cell body is because it doesn't have these. If it doesn't have them, it can't give an action potential. So at 1 here, we're just at rest, right? Resting membrane potential, minus 70 millivolts. Sodium, potassium pumps are working. And they are pumping 3 sodiums out, 2 potassiums in, every time they pump, using lots of ATP. And that's what establishes this resting membrane potential of minus 70 millivolts. And it will stay like that because this pump always works. So even if are those channels leaky? Absolutely. But as potassium leaks in, it gets pumped out. As sodium leaks, as potassium leaks out, it gets pumped back in. As sodium leaks in, it gets pumped back out. I mean, it's just constantly working to maintain them. We get a depolarizing stimulus. Is that excitatory or inhibitory?
Inhibitory. Oops.
It's excitatory because what's it going to do? Perhaps trigger an action potential. Hyperpolarizing potentials are never excitatory because they take you further away from threshold, not closer to threshold. At this point right here, we have a graded potential right here. So we would say a graded potential arrives at the hillock. And since it's at threshold, those gates are going to start to open, right? So here, since you're at threshold, what that triggers at step 4, we should say right here is actually where it triggers it, is right here, we get the activation gate opens, and you get sodium influx, right? So gate opens, boom, sodium rushes into the cell. And since there's a steep gradient for sodium, you're going to get rapid depolarization. So it's going to rapidly depolarize. Notice how the slope here is much steeper than the slope here. That's because we've got more channels opening, we've got a lot of sodium coming in. And then at point 5, here, sodium channels close. So right here, since sodium channels close, a decrease of p-means permeability, we get a decrease in sodium, permeability of sodium. So here we're going to have the sodium inactivation gate closes. So sodium flux stops. But by the time we reach here, notice it took this much time, well actually it took about this much time for sodium channels to open, but it takes that much time for potassium channels to open. So about the time that the sodium gate closes, what we're seeing open is a potassium channel now is fully open. So as a result, we have no more sodium flux. So here, sodium influx exceeds potassium efflux, so you depolarize. But right here, potassium efflux exceeds sodium influx, so you get a repolarization. So this rapid repolarization is due to this potassium efflux. Sodium influx, potassium efflux. And then you pass back through threshold. And while you're passing back through threshold, all of the gates are returning back to their original condition. The sodium inactivation gate is closing, or is opening, and the activation gate is closing. So it's just flip-flopping back around the way it was before, so we can start over, right? The potassium gate is starting to close, but the potassium channel closes slowly. Okay, here. And even at this point right here, the potassium channel is still leaking, meaning that the gate's not fully closed, right? And the gate doesn't fully close until this point right here. Potassium channel closed. But what happened at this point right here? Okay? At 8, right here, or well, I guess it's between 7 and 8, right here, potassium efflux exceeded sodium influx. What did I just tell you? More potassium actually leaked out than sodium leaked in. So the result of that is that the membrane is hyperpolarized. Okay? It is hyperpolarized. But it's brief because during number 8, what's working right there is that all of those sodium-potassium pumps that we have are all working, and we've got all the gates closed now, and those pumps are just working to push all the sodium that came out back in, all the potassium that went out. What did I say? All the sodium that came in, we're pumping it back out. All the potassium that went out, we're pumping it back in. So that at point 8 right here, these sodium-potassium pumps, the way I would say it is that they restore initial ionic condition. Right? The membrane potential was restored right here. But that's not, all the ions aren't in the right place, right? They're not all where we started. We got some sodium in and some potassium out. But here, we're back to minus 70, and we have the sodium and the potassium where it belongs. And what can we do? Start all over again. Okay? Now this period in here